Okay, so I'm going to go through some ACT questions. Then I'll go through just a couple more examples of even odd functions. So let's look at these three. So we're to number 38 of an ACT test, which is super awesome. But this first one, so which of the following is the graph of the region 1 is less than x plus y is less than 2 in the standard xy coordinate plane? Well, you might look at this and be like, I don't freaking know. But let's look at this piece right here. Okay, so we have 1 is less than x plus y is less than 2. Well, when we typically graph, we graph something like y is equal to something, blah, 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 blah. And we could also do like y is less than blah, 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 or y is greater than blah, blah, blah. Correct? So let's rearrange this to get it so it's just a y in the middle. Okay, so I'm just going to subtract the x from both sides, and whatever I do to one piece of this, I have to do to the other piece. So on the left, I have negative x plus 1, and that's going to be less than y, which is less than negative x plus 2. Okay, and now I can rewrite this piece right here if I wanted to be y is greater than negative x plus 1. And let's just graph that. So negative x plus 1, so that's the y-intercept. So I'm going to be crossing the y-axis right here. And then minus 1, that's going to be our slope. So I go down 1 over 1, down 1 over 1, down 1 over 1. So this looks like it's crossing here on the y-axis at 1 and the x-axis at 1. Okay, looking at that information there, I can tell you that it's going to be J. Okay, because none of these other ones cross at 1 and 1. But let's just continue to do this. So here, if this is saying y is bigger than that, so where this is bigger, this is pointing to the right, so that's going to be this side of the equation. Okay. Now let's look at the other piece of this. So we have, do this in this like ugly orange color. So y is less than negative x plus 2. Well, that means I'm going to go up 2. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. So then here's this. Which again, this is going to cross at 2 there, and this is going to cross at 2 there. So it has to be this one. But then this is less than that, so that's going to be everything to this side. So the place where those overlap each other is right in the middle, which is what that graph is showing. Okay. Okay, number 37, we want to know the difference between the mean and the median. So to find the mean, that's the average. We're going to do 3 plus 8 plus 10 plus 15, divide it all by 4, which, let's see what that would be. 10 plus 15 is 25, plus 3 is 28, plus 8 is 36. So this is going to be 36 over 4, which is 9. Now to find the mean, or the median, that's the middle. Uh-oh, what just happened? Oh, phew. That was scary. Okay, to find the median, this is the middle. So I'm going to cross those out. It's halfway between there, which would be 9. So then if I do 9 minus 9, we get 0. Cool? Okay, let's look at this one. Which of the following describes the true relationship between the functions f of x equals x minus 3 squared plus 2 and g of x equals 1/2 x plus 1 graphed in the standard xy plane? Well, if we look at this graph, right off the bat, I could tell you that, well, they cross at 2 places. So that means they are equal to each other at 2 places there. So looking down here, f of x equals g of x at exactly 2 values of x. That's true. F of x equals g of x at 1 value of x. Well, that's false because there's 2 values. F of x is less than g of x for all of x. That's not true because we have portions that are above and below both of this. So H and J are false, and these are not inverses of each other. So F must be the common, or the answer here. Okay. All right, so there's our ACT questions. Even, odd, or neither. So even means it is symmetric with the y-axis. So even is symmetric with the y-axis. Odd is symmetric with the origin. And then neither means it's not symmetric with either. So these odd functions, if we were to flip this around 180 degrees, it would look the exact same, which means that this, like if I was to take my iPad, and I know you can't see me doing this, but if I was to be able to flip my screen upside down, it looks the exact same to me. Okay, same with this one. So these are both odd. These ones, if we were to fold it along this line right here, they fold right on top of each other, which makes them even. And these ones, we could fold this right here, and that would be a line of symmetry, but it's not the x-axis, or it's not the y-axis, and it's not the origin, so that one doesn't work. Same thing with this one. I'm sure there's a line like right here that we could fold it over, but that is not an even or odd symmetry. Okay. Okay, so to check this algebraically, if we plug in negative x, and you get out what you started with, this means it is an even function. Okay, if you plug in negative x and you get out the exact opposite of what you started with, it is odd. And if you get some mixture, then it's neither. Okay, so if we look at this first one, I'm just going to plug in negative x. So I'm going to do f of negative x. This would be negative x squared plus 3 times negative x. Well, negative x squared, that's going to be negative x times negative x, which would be a negative times negative is a positive, and then x times x is x squared. So that one stayed the same, but here if I have 3 times negative x, that means a negative 3x. So this sign stayed the same, but this sign switched, which means that they aren't completely different. It's not completely the same, so this would be neither. Okay. This one, if I plug in negative x, I get 3 times negative x to the 5th. Well, this negative x to the 5th, I have negative x times negative x times negative x times negative x times negative x. Negative negative is a positive, times a negative is a negative, times a negative is a positive, times a negative is a negative. So this is going to leave me with 3 times negative x, and then to the 5th, which is negative 3x to the 5th. So that is completely opposite of what we started with. It switched signs, right? So this would be an odd function. Okay, this one's a little tricky, I guess. There is no x here. So if I plug in negative x, I just get 3. There's nothing to plug x into, which means that this must be an even function because it is the exact same. Okay, and this last one, so if I plug in negative x here, I get the square root. I want to write this down here a little bit more. I need to give myself more room because I write too big. So if I have the square root, f of negative x is the square root of the absolute value of 6 times negative x cubed plus 2. So let's work out this part right here. Well, negative x cubed is negative x cubed, but we're still inside an absolute value. And the absolute value of a negative is a positive. So really, this is saying this is the same thing as 6x cubed, positive, because whatever we get out of there is going to be the same, whether it's positive or negative, plus 2. So this one is even. Okay. Remember, if you have an absolute value, it always comes out positive. So on that note, I do want to talk about something. So I'm going to bring up, can I just erase. All right. On your test, you ended up getting, let's see if I can make something up. Oh, I probably can't. But this was number 29. What the heck? No. All right, this is number 29. So you ended up getting an absolute value of like 3x minus 4 equals negative 2. Okay, and yours might have looked a little differently. That's fine. This negative right here is what throws off this problem, okay? An absolute value can never equal a negative. No matter what numbers we plug into here, the number that it spits out of this function will not be a negative number, okay? So that means the answer to number 29 was no solution. Okay, I got lots of emails about that, so that's just kind of to go over that. If you can never have an absolute value set equal to a negative, if that happens, you get no solution.